So the topics we're going to cover today are as follows. First, we'll discuss about principal stress and maximum shear stress. After we discussed about principal stress and maximum shear stress, we'll solve a few example problems of plane stress. And then we'll move on to like a three-dimensional case and discuss about general stress state and transformation. Here, I will not gonna tell you like an exact way of doing general stress state problem. I will just tell you some special cases that we can handle in 3D, and based on that, in next class we'll talk about a thin walled structures. Okay, so let's start from the first topic, principal stress and maximum shear stress. And here, by mistake, I organized the example problem first, and this lecture in later part. So I will start from the later part of lecture note and move on to example problem later. So here's the lecture for lecture note for principal stress and maximum shear stress. Okay, so as I told you, we are considering same stress state, but depending on our viewpoint, xy coordinate, x prime, y prime coordinate, we can have different reading. And regarding the stress transformation, I just told you that it's easy to memorize the equation using Mohr circle concept instead of theta degree rotation. If you do 2 theta degree rotation, and that will give you the numbers, okay, like sigma x prime, tau x prime, y prime, and sigma y prime. So the first question I can ask that is related to principal stress is that at which angle theta tau x prime y prime will be 0. Okay, so in other words, if we choose a coordinate system such that like a tau x prime y prime is 0, it will be like a principal axis. It is called principal axis, and those normal stress is called principal stress. And this question is about how to find that angle theta. Okay, so of course from equation 2, which is this equation, no, not this equation, maybe equation 3. So if you put tau x prime y prime equals to be 0, you can obtain the expression for theta directly. Okay, so if you plug in tau x prime y prime equals to be 0, and if you solve this, then you're gonna get tangent to theta equals to be 2 tau xy divided by sigma x minus sigma y. You can obtain this angle in this way, or from Mohr circle, what you can do is you can do either 2 theta rotation in counterclockwise, or this 2 theta rotation in counterclockwise. Then you can find the angle. And actually, if you look at this 2 theta angle, what you can find is that the length of this guy is sigma x minus sigma average, which is sigma x minus half sigma x plus sigma y, which is sigma x minus sigma y divided by 2. And the height of this guy is of course simply the absolute value of tau xy. Okay, so from simple geometry, tan 2 theta should be tau xy absolute value divided by sigma x minus sigma y over 2. And you can see how this equation comes out. Okay, of course, you gotta be careful about the sign because x represents minus tau xy. Okay, other than that, you can either use a Mohr circle, or you can use this equation and try to obtain the angle to find the principal axis. Okay, so what you can realize is the p represents principal axis at theta equals to be theta p. In that coordinate system, x prime, tau x prime, y prime will be 0, and it means pure normal stress, okay, pure normal stress state. So let's solve one example problem. The example problem we're going to consider is this. With respect to xy coordinate system, somehow we are on the pure shear stress state. And after rotating some angle x prime y prime, we want to see at which angle we're gonna only have a normal stress component, and how much angle we should change. Of course, we know the answer from the our discussion in torsion chapter, it's 45-degree angle, but let's try to find the number from our equations. First of all, out of this numbers, plug in 0, 0 for sigma x, sigma y, and tau xy equals to be 40. It must be infinity, and tau 2 theta p becomes infinity when theta p equals to be 45 degree, or 2 theta p it becomes to 90 degree. Okay, so you can find the angle using this equation, or starting from Mohr circle, you can also find the answer. As I told you, you need three numbers, x, y, and O. Okay, so x is given as sigma x and minus tau xy, so that you plug in sigma x equals to be 0, tau x is 40, so you plug in minus 40 because it's minus tau xy. For y, you plug in sigma y and tau xy. So if you plug in 0 and 40, y is here. Okay, and regarding the O, you have sigma x plus sigma y divided by 2 and 0, and this guy, because sigma x and sigma y is 0, simply 0. So origin is here. After making 3 points, then you can complete the Mohr circle quite easily. Then what you can see here is the vertical reading is the reading for tau xy. If you consider this 90-degree rotation of xy, y prime is here, x prime is here, then this will give you the normal stress component at principal axis. And what you can find is, because 2 theta is 90 degree, theta must be 45 degree, and at that specific coordinate system, when this is 45 degree, the reading must be 40 and negative 40. Okay, so this is what you can get from the discussion. So as I told you, we call the x prime y prime coordinate system such that tau x prime y prime equals to be 0 as principal axis. Okay? And actually, without obtaining the principal axis information, we can obtain the maximum normal stress and minimum normal stress at principal component. Because if you think about the geometrical meaning of Mohr circle, even though you don't know this angle specifically, Mohr circle tells us the information about the maximum stress that we can have as we rotate the coordinate system, and the minimum normal stress we can have as we rotate the coordinate system. And simply, the r square, the radius of a Mohr circle, is given as this guy plus this guy squared. Okay, so if you know the radius of a Mohr circle, then the maximum should be sigma average plus r, and minimum will be sigma average minus r. Okay, so with this, you can also quite easily obtain the maximum and minimum normal stress at principal axis. The second question that we can ask is about how to obtain maximum shear stress and the coordinate system that that have the maximum shear stress reading. Okay, so at which angle the tau x prime y prime maximizes? That's the question. And from the Mohr circle, if you recall what's the meaning of Mohr circle, the reading in shear stress is the vertical axis. Okay, so when you have the maximum reading in vertical axis, then shear stress component tau x prime y prime will maximizes. Okay, and that point actually occurs when x prime y prime and this origin aligned completely vertically. Okay, in that case, sigma x prime and sigma y prime will be same as sigma average, and the reading of the vertical axis will give maximum shear stress. Okay, so we can obtain the angle required to obtain the maximum tau x prime y prime from this angle 2 theta s, or s means shear stress, and instead of using Mohr circle, using the equation 1, where's the equation 1? Using this equation, when sigma x prime becomes sigma average, when sigma x prime equals to be sigma average, you can obtain the tangent to theta s, okay, which is the angle required to have the maximum tau x prime y prime. Okay, so yeah, these two angle is very special because, as I told you, brittle material breaks, under the tension, or breaks along the axis that give rise to maximum normal stress. Okay, so in obtaining the failure plane of the brittle material, such as the choke in our torsion chapter, it is really important to obtain principal axis. And as I told you, the ductile material, such as rubber, fails along the maximum shear stress. So maximum shear stress, after obtaining the coordinate system where the maximum shear stress occurs, then you can obtain the failure of ductile material. For example, if you have this cylindrical sample made out of chalk and made out of rubber eraser, then you try to give some torsion here and there. For the chalk, which is brittle material, the maximum normal stress occurs at 45-degree angle. So yeah, you can expect that the failure plane of a chalk is 45-degree. However, if you do like a pure torsion for the rubber eraser, yeah, it will fail at this surface, because this is the surface with maximum shear stress and maximum shear stress and smallest normal stress. Okay, so it's really important to obtain the axis where we have maximum normal stress and minimum normal stress, and the another axis where we have maximum shear stress component tau x prime y prime. Okay, so in next video I'm gonna give a additional example problems related to this lecture content.